A common question that I hear is, what makes servo motors different than other kinds of motors, like a DC motor, an AC motor, stepper motor? Well, the answer, surprisingly, is that a servo motor isn't any different than any of the rest of those. You can have AC servo motors and DC servo motors, and they can be built with stepper motors. The difference is that in a servo system, we use the motor, but we automatically attach some sort of feedback device, usually an encoder, right onto the frame of the motor, so that we have both the output and the feedback all into one unit. That's what makes it called a servo. So technically, the motor part of it can be driven just like an AC or a DC motor. But what advantage do we get by connecting the feedback to it? Well, the whole point of feedback is just to ensure that when we told the motor to go to a certain speed or a certain position, that it did in fact get to that position or reach that speed. Otherwise, we're just supplying voltage and hoping that the motor is achieving the goal that we set for it. The way we connect those, though, is a little bit more complicated. So to say that they're no different isn't quite true. Although the motor part may be similar, we do have to rely on what we call servo amplifiers, or sometimes servo driver boards, to ensure that we can drive them properly. So these are going to have a supply of power, a supply of control from our control system. That might also be just a network port. We also have the connection going out to the motor and the connection going out to the encoder, the feedback portion. So those are four different components of the servo driver that we need to consider: supplying power, supplying input signal, supplying output power to the motor, and supplying feedback signal. These servo motor driver boards, or these servo motor amplifiers, are used to increase the voltage and the current instead of just relying on the signal. For example, the PLC, perhaps from an Ethernet or a Profinet network, cannot possibly deliver the amount of power that it takes to run a large motor just from that Ethernet port. Similarly, from digital outputs, even if we can pulse a digital output on and off quickly enough, we can't possibly do it with enough power to drive the motor. So the amplifier board simply is a translator to turn the control signals from the controller into the power signals out to the motor and verify that we're reaching our intended target as quickly and effectively as possible. There's all kinds of control strategies that these servo drivers boards use to make sure that they reach that target properly, but at the end of the day, what we really need is a motor that can drive to where we want and stop exactly where we want at just the right speed and just the right time to produce the intended result.